This section explains the direct preference optimization, DPO model and code implementation. Let's first look at the DPO model overview. DPO is designed to train a language model by comparing pairs of responses and directly optimizing the model to rank the chosen response higher than the rejected one. The key idea is that rather than using reinforcement learning with a separate reward model, DPO uses the difference between the log probabilities from the policy model, the one being trained, and a reference model, which is kept frozen, to derive a loss function. For policy model, this is the model we want to train. It generates responses and ranks them based on human preferences. For reference model, a pre-trained or fixed model that serves as a comparison for the policy model's responses. Its parameters are kept frozen during training. Key components of DPO. 1. Response pairs. Chosen response. The response that is preferred by a human annotator. Rejected response. The response that is rejected or not preferred by the same annotator. The goal is to train the policy model such that it generates responses closer to the chosen response, rather than the rejected one. 2. Reward calculation. DPO uses a reward function based on the log probabilities of the policy and reference models. For each pair of responses, the reward for the chosen response is calculated as follows. Similarly, the reward for the rejected response is as follows. Here, P-policy is the probability of the response according to the policy model. P-ref is the probability of the response according to the reference model. 3. Logits calculation. The difference between the chosen and rejected rewards is scaled by a temperature parameter beta to compute the logits used in binary cross-entropy loss as follows. 4. Reward calculation. The loss function used in DPO is the binary cross-entropy loss as follows, where sigma logits is the sigmoid function. The target label for each pair is always 1, indicating that the chosen response should be preferred. DPO training process. In the training loop, DPO performs the following steps. 1. Forward pass. Compute the log probabilities of both the chosen and rejected responses for both the policy model and the reference model. 2. Reward calculation. Calculate the rewards for both the chosen and rejected responses as the difference in log probabilities between the policy and reference models. 3. Logits calculation. Compute the logits using the formula logits. 4. Loss calculation. Compute the binary cross-entropy loss between the logits and the target, which is always 1 for the chosen response. 5. Optimization. Perform backpropagation and update the policy model's weights using an optimizer. Now we implement the DPO code. Simple language model class. DPO trainer class. preference dataset class. Testing the DPO model.